In this tutorial, I'll show you how to use universal bridge for Thyristor Controlled Rectification. Okay, for that I'm browsing my library and under Simscape Electrical Specialized Power System and Sources. Here is our AC voltage source, and then we need universal bridge. Okay, universal bridge is under Power Electronics. Here is our universal bridge, and then we need a power grid block. Okay, and for universal bridge number of bridges are is 2. As in this video especially we are focusing on single phase. Okay, click on OK and connect the AC source to AB, and okay, and we need pulse generator block for giving gate signal of the thyristor. For that we have to go sources and here pulse generator. Here is the main importance here for generating pulses of thyristor. Especially we need 4 pulses. I'm setting up 1 pulses. Here firstly we have to check our AC voltage source. Here frequency is 60 Hz. Okay, so here period will be 1/60. Pulse width 5 is okay, and phase delay will be 1/60 as this is 60 Hz. And let's take a variable called delay. Sorry, alpha. This is a firing angle, and it's over 360. Okay, now click OK and copy another pulse generator block, and just we have to add 180 here, and click OK. And we have to we need max because we need 4 pulses. Okay, type max, and here input will be 4 because for single phase full bridge we need 4 gate pulses. And here this is our gate 1, and gate 4 will be same as gate 1. Okay, and gate 2 and gate 3 will be same. Now okay, now I'm taking a voltage measurement block to measure the output voltage. Then we'll convert it to smooth wave. Okay, first check this whether it's working or not, and we need a scope block. Connect this, and okay, now I am setting my model parameter like max step size 1e minus 4. Click OK and run this model. Sorry, I haven't connect the gate signal. It's now okay. Now run this. And we have to assign our alpha value here equal that 40. Okay, now run this model. Check the output voltage. And now you can see this is our output voltage. Okay, now if I set as alpha equals 0, we can clearly see whether it's working or not. Okay, alpha equals 0, and now stop time 1. Now you can see this is looks like a full wave rectifier circuit. Okay, as there is there I will set alpha value as 0, and let's set alpha equals 90 and run this model. can see here our output voltage. Okay,